hello everybody. In the last lecture of the fluid mechanics, we have discussed about thermodynamic properties of fluid. Okay, so I have just introduced all the properties there, the thermodynamic properties of the fluid. So now we are going to discuss about each one in detail. Okay, so let's start. So first, I have told you that the velocity is the most important properties of the fluid. Okay, so one second, yeah. So velocity is the most important, right? I will write it as a VBI. Okay, velocity is the most important, and the very consecutive most important other than the velocities are pressure, temperature, and density. Okay, so we will discuss each one one by one. Okay, so first I want to make note of some important points before going in hand to each one one by one. Okay, so I want to discuss like all the properties of the fluid. So let me write it here, then it will be better. Okay, so properties of the fluid. Properties of fluid, these are determined by the thermodynamic condition and the state of the fluid. Okay, so thermodynamic condition, okay, thermo condition and a state of the fluid. Okay, so based on the condition of the thermodynamic condition and the state of the fluid, we will able to measure the properties values. Okay, so like according to the thermodynamic condition and the state of the fluid, we will able to measure what's the value of velocity, pressure, and temperature. Okay, for example, let's say we will discuss briefly here for a single phase property, single phase fluid. Okay, for example, water or air. Okay, the single phase means what I mean is especially I will write it here, single phase. Okay, single phase. Okay, so what does this single phase mean? So for example, if you boil any water, I mean you heat any water in a tub or anything, you will see that in the tub the water is present in two phases, right, simultaneously, in gaseous and in liquid phase as well. But when you go to deal with the both fluid and the gaseous part of the water, you will have to deal with the both of things, and that concept is known as multi-phase fluid. Okay, and now here we are going to deal with single phase. I mean either water liquid is present or water gases, I mean water vapor is present. Okay, so for single phases, generally for knowing the property of the fluid or knowing the state or the thermodynamic condition of the fluid, we need at least two properties to be known. Okay, for example, if you know properties pressure and temperature, you will get to know density, right? Density is function of pressure and temperature. If you know density or temperature on anything, or you will get to know pressure or density, anything from any of the two condition is known, then you will able to get all the properties of the fluid. Okay, I mean you will able to understand the state and of the fluid. Okay, for example, if you know pressure and temperature, okay, so from these two you will able to get density as a function of temperature and pressure, and you will know the enthalpy as well. Okay, which is pressure and temperature. Okay, and as a mu, I mean viscosity, as a function of pressure and temperature. Okay, so we will able to get the state and the thermodynamic properties of the fluid. Okay, so I mean like see, one dot has to be come in mind. Okay, like I will write here, see, I have told you like all these properties are thermodynamic property, right? I have told you like this one are thermodynamic properties of the fluid. Okay, so what does this thermodynamic properties says? Okay, PERTIS. Okay, so what does this thermodynamic properties do or tell about any fluid? Okay, so first of all, it describe about state of the system. Okay, describe the state of system. Okay, okay, so what does the system mean? System means let's suppose I have a box containing multiple particles here, right? okay, that are having means these are the collection of the matter and having fixed identity, and that will interact with the surrounding. Okay, so other overall part other than the system is surrounding, and this one is system. Okay, I mean this one is system and other part are surrounding. Okay, surroundings. Okay, so thermodynamic properties means like say system, you have considered a system. I mean what the system, like a collection of matter and that are having fixed identity. Okay, so most of the cases you will see that the system, the particles are in the static, I mean static systems, like the system are not moving or the particles are not moving. I mean this box is not moving, right? If you chose this box, this I mean this box, so this box would be static, right? Most if you have studied in your school days, most of the system that you have studied in thermodynamics subject, that the system are in static condition. Okay, but as we are using this thermodynamic properties in our fluid case, so as you know the fluid mostly are in the non equilibrium case. I mean the fluid are flowing. Okay, uh, they are in the motion. Okay, so they are flowing. So the question must come into your mind, like whether these thermodynamic properties are useful in case of flow fluid as well or not. So the answer is yes. Okay, so from a statistical argument, like see, in a gases at normal pressure, and for even for liquid that is possible. So in gases at normal pressure, an enormous number of molecules collisions occur. Okay, over a very short distance of water, like 1 micrometer or 0.1 micrometer, like that. So that a fluid subjected to certain changes rapidly adjusted itself towards equilibrium. Okay, that means the particles are adjusting itself, like reaching to the equilibrium. That means, so we can say that this the fluid flow that we will use in all over the courses, that fluid is flowing. And if we consider a box here like a structure, and even though these particles are moving, I mean it is in the non equilibrium, but from the statistical argument we can say that these particles are approaching towards equilibrium. Okay, I mean just about to reach the equilibrium. That's why we can use these thermodynamic properties. Okay, so I hope you know that why we are going to use these thermodynamic properties in case of fluid. Okay, so I guess you know, you all understand about this. Like this one is very important thing, that like a very unhygienic thing, like people have to occur to the people, like in their mind, like why this is applicable to fluid or like that. Okay, so I hope you this will find you useful, like why we are using thermodynamic properties here. Okay, so now I'm going to discuss each thing in detail wise. Okay, so the first thermodynamic property that we have discussed is pressure. Okay, so first I will discuss about pressure. Okay, so what's the pressure? Okay, so for example, let's suppose, I mean this is a fluid continuum. Okay, that is the packet of the fluid. And what does the pressure means? A compression stress will occur. Okay, compression stress will occur from the all over the side, and that is known as the pressure. Okay, just the simple definition. I have discussed this as well in the previous, I guess in the first lecture, that where I have discussed, where I have differentiated between the fluid and the solid. Okay, there I have discussed this. Okay, so now what's the pressure? You know, compression stress at a point in a static fluid. Okay, so this one is static fluid, and this is a static compression. Okay, static compression stress, I mean compression stress. Okay, this one is static fluid. Okay, so now you are able to understand what the pressure mean. Okay, so means like why pressure is important for a fluid. Okay, I mean why pressure is playing an important role in the fluid, or what's the role of the fluid. So whenever a flow is getting generated, I mean flow developed, who have seen like fluid is in the static or in the fluid in the motion. Okay, so flow developed means fluid into the motion. Okay, motion developed in fluid. Okay, obviously in the fluid we are studying the fluid, so obviously fluid. So motion will be getting developed or flow developed. The reason behind this is pressure difference. Okay, so the pressure difference is the main reason. That's why this flow getting developed, I mean the flow motion will happen. Okay, so that's why this pressure is important. I mean pressure difference, or we consider pressure gradient. Okay, that means delta p by delta x. Okay? over the some length and some pressure difference is seen over some length, then the fluid will get into the motion. Okay, so like some important facts that I will write here, like if flow is at lower speed, that means flow at lower speed. Okay, so at lower speeds the pressure is not so important. Okay, the magnitude of the pressure, I mean absolute magnitude of the pressure, magnitude of pressure is not so important. Okay, means it does not play, it does not play any vital role here. Okay, but when at high speed, in case of especially compressible flow, these are very sensitive to the magnitude of pressure. Okay, so I will write here at high speed it is very sensible to magnitude of pressure. Okay, magnitude of absolute pressure is very much important in case of high speed flow. Okay, so that's all about the pressure, and now we will discuss about the temperature. Okay, so we will discuss it quickly. So temperature, second thermodynamic property is temperature. Okay, so how is this one is related to the fluid? So it related to the fluid, like it represents or depicts internal energy of the fluid. I mean, if the temperature is high, that means internal energy of the fluid is high. U means internal energy. Okay, this is the definition of the internal energy. So if the temperature is high, then the internal energy of the fluid is high. We can say that. Okay, and how, like, the temperature point is not so important in our case, where we are discussing many dynamic effect of the fluid. So whenever there is a heat transfer effect, if you see any heat transfer effect in fluid, like convection or anything, heat transfer effect, temperature is very important there. Okay, temperature is very important in that cases, but in dynamic effect these are not playing very vital role. Okay, so we are not going to deal that much in the temperature. Okay, now the third third thermodynamic property that we are going to discuss is density. Okay, so in density, the density is defined as the mass per unit volume. Okay, that means rho is the definition of the density, mass per unit volume. Okay, so like density will have two different property in two different kind of fluid. Okay, so density in case of gas and in case of liquid. Okay, the density also this is defined for the whole fluid domain, but the property of the density varies largely for gaseous and the liquid. Okay, so like in gaseous, density is highly variable. Okay, and it, like, highly variable means what? Density is almost proportional to the pressure. Okay, if we increase the pressure, density will increase in case of gases, but in liquid it's almost even constant. Okay, almost even constant, that is rho is not a function of pressure and temperature. However, it is, but not in very significant or very comparable way. Okay, significant or comparable way. Okay, so I mean, if you increase any pressure by 220 times, by factor of 220 times, the pressure in the liquid will get, I mean density in the liquid will get increased by only 1%. Okay, so that this density in the liquid is almost remains constant. That's why this liquid that means the fluid which are having density having constant, or liquid which are having constant density, then that is known as incompressible fluid. Okay, I think you all know about this, but I am just writing here just for information. Okay, and this is known as compressible. Okay, compressible means if you compress this, I mean if you increase the pressure here, then the density will increase. Okay, that's why it's known as compressible. That means it can be compressed. Okay, okay, and now some important parameters that we are going to discuss now. Age, one of them age. So all of these are important. Okay, so fourth one is specific weight. Okay, so like what's the definition of the specific weight? Okay, so it's denoted by gamma, a Greek word, and what the specific weight means, it is mean by, it means weight of fluid per unit volume. Okay, so weight of the fluid per unit volume, so it's just like gamma is equal to rho multiplied by gravity. Okay, this is per mass per unit volume, and if you multiply by gravity it will become weight per unit volume. Okay, so this is the only thing. For earth we are taking G as a 9.807 meter per second square. Okay, for our cases we will only say 9.8037 meter per second square. Okay, and like why we are discussing this specific weight, I mean what's the importance of this? Okay, in the our fluid case, so in the dynamic effect of a fluid, so a specific weight is very useful in case of hydrostatic pressure. Okay, very important in hydrostatic pressure, so what does this hydrostatic pressure mean? Okay, so hydrostatic pressure means when a fluid is there, like any pipe kind of thing, and fluid is filled here. Okay, so there must be a pressure will be generated here due to the fluid, that is filled in between the height of that. Okay, so this the density that you experience here, then that is known as hydrostatic pressure. That means the fluid is not moving. Okay, it is in a static condition, and however in the static condition as well you are feeling some pressure. Okay, then one is known as hydrostatic pressure. So we will solve a lot of problem in the second chapter regarding this hydrostatic pressure, so you will get more clarity over there. Okay, so till now I am just passing over quickly. Okay, just to aware of that some properties kind of thing are available, like specific weight or something. So the fifth property is specific property. This is also very like very fundamental kind of thing, so you will know specific gravity. Okay, so it is defined as the ratio of the fluid density to the standard reference fluid. Okay, I mean we will compare the two fluid with their respective density. Like for any gaseous particle we will define it as specific gravity. Okay, sorry, it's not wrong. The specific gravity is defined means denoted by itself as a Hg. Okay, so if you want to define a specific gravity for any gaseous, you will write as a rho divided by rho of air. So here this is the density of the any air that you want to find the specific gravity of that fluid. So you will take the density of that fluid only, or that gas only, and in the reference you will take density of the air. Okay, usually we will take at 1 atm. Okay, and it is will be around 1.002 kg per meter cube, and you will take the density of your required fluid. Right? And if you want to find out the specific gravity of any liquid, I mean, okay, so liquid fluid, here it is for gaseous fluid, right? So sorry. Okay, SG of any liquid. So you will write the density of the liquid, that you have to find a specific derivative of that particular liquid, and in reference you will take water. Okay, I'm just taking it a water, I'm just giving example. Okay, you can take whichever liquid you will want to use in the standard reference. Okay, so that's all. So this is the thing that we will discuss here. And now one more property remain. Okay, so and that is potential energies and kinetic energies in fluid. Okay, so all of you know about potential energy and kinetic energy. Just I will discuss it in the term of fluid. Okay, the fluid dynamics term. Okay, so for example, any fluids, if fluid particles are there in a box or any kind of thing, we will take a control volume kind of thing. So some fluid particles are there, right? So how many forces are there, like how will you calculate the energies are there, how many types of energies are there? Like you will have some intuition in your mind, like what are the things that are present here, the forces kind of thing or the energy kind of thing. So for now we can say that there are two kind of things present here. The first one is molecular activity. Okay, that means they are having some velocity and they are colliding each other, like anywhere going random kind of things, and they are moving in their mean free path. Okay, and another thing is there is molecular force of attraction. Okay, so there must be a molecular bonding force between two molecules. So okay, so there are two thing present there. One is just the tandem motion, that is molecular activity, and another one is molecular force. Okay, so I will just write it here for your clarity. So this zigzag motion, that is known as molecular activity, and this is known as molecular bonding force. Okay, molecular bonding force. Okay, and another thing is there, that is known as internal energy. So it is also present there, and that is calculated with the help of temperature. So the temperature is the direct representation of the internal energy. If the temperature is high, so the internal energy is high. If the temperature is low, internal energy will be low. Okay, so we have seen here there are three types of forces or three types of energies are present. Okay, so and these are the commonly accepted argument for the static fluid. Okay, that these three energies are present for the case of static fluid. Okay, so we will now define total energy stored per unit mass in the fluid mechanics. Okay, so we will define total energy per unit mass. Okay, total energy stored in a static fluid. Okay, a static fluid per unit mass, and it is defined by E. Okay, and it will be calculated as U. First one is internal energy, second one is this molecular activity. So this will be calculated as a kinetic energy, right? It is having some velocity, and like how this kinetic energy is defined. So it's known as its kinetic energy equals the work required to change the speed of the mass from 0 to the velocity v. Okay, so we are assuming that the particle having initial velocity as a 0 and final velocity as a v. So the kinetic energy or the work required to generate this velocity is half mv square, but here we are taking per unit mass, so we will take half v square. Okay, that's all. And if we see this molecular bonding forces, that is if we consider the gravity kind of thing. Okay, so it will be defined as minus gr. Okay, so it will minus gr, but according to our conventions we will decide z as a upward condition. Okay, so this will become positive. The total energy per unit mass will come as 1 half v square plus g into z. Okay, so this is the total energy stored in a fluid. Okay, so this is very important in case of problem solving skill that we will see in case of if we solve the problem, this term is very useful. Okay, this is very prominent equation in this will decide the everything. Okay, of the any fluid if we deal with the energy. Okay, so as I've told you, so just keep in mind, like U. That means internal energy is a function of pressure and temperature for a single phase substance. Okay, and this potential energy and kinetic energy are kinematic quantities. Okay, so it has nothing to do with thermodynamic properties. Okay, so, or anything about pressure and temperature. And one thing, please remember, this is only valid for single phase fluid. Single phase fluid. If you want to deal with the multi-phase fluid, like both vapor plus, I mean, vapor plus liquid condition, then that is known as multi-phase. Okay, and we are not going to deal with the multi-phase here in this course. Some other books are there, or you can read in the other courses. Okay, so till now we have discussed all the thermodynamic properties here. So in the next lecture we will learn the state relation for gases and the liquid as well. Okay, that's mean like perfect gas equation or the perfect liquid equation. Like just for curiosity, if you want to search like whether a perfect liquid law is available or not, just like perfect gas equation. Okay, so just search about it and be curious. And that's all for this lecture, and then keep learning and good.